today on campus during Engineering Expo, and it's very much part of transportation engineering. Okay, so being a good professor, obviously I'm biased, I got to have a quiz, right? We always have a quiz in class. So question number one, what does it mean when the light is red? Oh man, you guys are good. All right, next one. What does it mean when the light is green? Wow, I got to make this class harder. The next one. What does it mean when the light is green and you want to turn left? Uh-oh. One wrong. So what's the criteria? Right? Yeah, so if we have oncoming traffic, so what does it really mean? It really means yield, right? So now we have a situation where green means two different things, doesn't it? Depending upon which direction you're going. What does it mean when the light is yellow? Oh, I knew you were going to say that. Right? What does it really mean? Yield. So I hear yield, I hear step on it, and I hear...
slow down.
What else? Yeah. That's exactly right. You know what the yellow means? It really means, all it's telling you, and by definition, it simply means we're switching from green to red. It's a legal definition. There's no yield to it. There's no slow down, speed up, hurry up to get through. It just means we're transitioning. In the old days, we just went from red to green, or from green to red. Right? Without that transition, it was too abrupt. So we said we needed to put something in there to let the driver know that that transition was happening. And that's what we did with the yellow. So the yellow just simply means that we're changing. Now, the problem with the green has led to some changes that you're going to see here sometime very soon. And with permissive left turns, or when you take a left turn, we're now going to be using the flashing yellow arrow. So this is something new that's coming down the pike, and you can see how it operates there up on the upper left. You can see that flashing yellow arrow there will now be your signal for making permissive left turns. So you'll be seeing that coming to an intersection near you very, very soon. All right, Andy. Now, the next thing I want to talk about is detection. And I showed you in the top of that cabinet there that there was some loop detector amplifiers and other elements here. So the question is, what do we do with this detection? All right? So now, we have situations where we see things like this. How many of you have seen something like that in the roadway? So we have these squares cut into the system, right? And what are they? Does anybody know? Who said that? Oh man, you're on top of it. All right, you're going to get some AP credits for coming into civil engineering there. All right, that's right. They're inductive loop detectors, right? And we see them. We have them illuminated up here on the board. And here's my little model. So an inductive loop detector is really just a turn of wires. All right? It's just a turn of wires that's in the roadway. And what are they designed to do? Detect vehicles, right? Why is that important? So we can change the lights, but we can change the lights in a dynamic way such that the vehicles control the movement, right? So instead of setting everything for green 30 seconds, yellow 5 seconds, red 10 seconds, whatever, and then regardless if one car comes or 1,000 car comes, right? We have all experienced that, right? Where you come up, the light's red, no one else is there, and you go, why? Right? But in situations where we have this type of control, the detection of the vehicle will allow that to change and make the system overall much more efficient. So how does it work? Well, my ring keeps doing it here by accident. But anytime something metal comes over this loop, right, it senses. So that change in inductance on that loop. So the metal in your vehicle will change. And every time you come over that loop, it detects you. Now, where's the most sensitive part of the inductance loop here? Where do you think? Okay, the square thing. That's good. So what part of the square thing? So the edges, right? So right on top of the wire. So just some tips. If you're riding your bike, you want to get detection, line your bike right up on that saw cut. All right, and that should be enough metal in your bike in order to trigger that system. Also, if you're the the most sensitive part is really at the corner. So you want to pull up and get at the corner. But there's a number of ways to make that detection operate. Okay? So that's a quick overview of just how detection works on a typical traffic engineering system. Now, how many of you have seen these? What are they? There's only one answer. Right? So it's a pedestrian signal. And although I know the answer to this question too, I'm going to ask it anyways. What happens when you push the button? You guys, it's like clockwork every time. It's perfect. Nothing, right? Absolutely nothing. Why is that? Because us transportation people like to fool you, right? You think you're getting some service, but you're really not. Actually, that's not true. When you push a button, it's just like what I demonstrated to you here, all right? It's just another form of detection because most of us don't have a lot of metal in our body. We can't put a little inductance loop out there like we do for vehicles, right? But we can put a push button. So the pedestrian can push the button, send the same signal to the controller cabinet, and say, I want to walk. Give me some service. Okay? Now, there's a number of different types of indications that come through. So you used to say walk in the old days. Now we just show a person, right? So a white person in that walking mode, and that means you can walk. Good. If I have my hand up and it's solid, what does that mean? Now what if I have my hand up and it's flashing? Oh, come on. So this is another one of those mysteries of transportation. It means you're going to get the don't walk very soon. That's right. So if this is my curb, and I'm standing here and the flashing hand comes on, what do I do? Stop, right, or run. Right? It actually, by definition, it means if I haven't left the curb, I should stop. If I've left the curb, I have enough time of flashing to safely walk across. So we time that flashing indication to make it long enough for a typical person to walk across the roadway. Okay? Now, sometimes we're getting smarter as transportation folks. Sometimes now we're putting these. How many of you have seen one of these countdown signals? So they're starting to become more and more popular. And when we do that, that tells you how much time you have to what? You got how much time you got to get across the roadway, right? Do you like that? No, why not? Scary. Scary? So the question, I mean, the debate, if you will, in the transportation community is, it's counting down to what? When it gets to zero, what's your, where are you? What's your chances? Right? So some people, when it gets to zero, the opposing traffic's already coming. Some people, when it gets to zero, there's still plenty of time. So that's kind of the debate, just exactly what zero means in the transportation environment. Now, I have another little device up here, and it looks something like this here. Now let me start it. Did you put a bomb in this thing? Yes.
Was I not supposed to?
I don't know why it's ticking. It's not supposed to tick.
Sorry. Oh.
What is that? So it's a ticker. Actually, I think it is supposed to tick, right? And as I talk louder, it should tick a little louder, and as I walk away, it should tick a little quieter. Although it wasn't very dramatic, it does. Right? What is that? Yeah, who said that? Right there. Andy? How about a ball for that young lady?
Who answered it?
It's for people who are visually impaired, right? But actually it works for all pedestrians, and I'll show you why. So first of all,